Hello everyone, this is Dr. Mabruka here. Welcome to Logic Programming and Computational Thinking. My name is Mabruka. I am your course leader for the Artificial Intelligence and Computer Science. I'm also going to be teaching you this course. I got PhD in Communication Systems in Ad Hoc Networks, MSc Computer Networks, BA in Computer System Electronics. So as you can see, I have a broad, wide background, so I can help you with any course, hopefully. I organize Swansea TEDx talks, and I'm a member of the IET Wales Committee. In 2019, I was nominated for the Women in IT Excellence Award. I was finalist in the Role Model of the Year category. In today's lecture, we're going to be introducing you to the computing world. I'm going to be giving you some definitions you might know, you might not know about software, hardware, peripherals, and so on and so forth. We're going to be covering concepts like computer memory and how data is stored in the computer. So let's dig in. People use computers everywhere these days. School for writing papers, research, work for analyzing data, presentations, businesses, and so on and so forth. Home for just paying your bills, or shopping online, or maybe even playing computer games. What are some of the ways you use your computer at home for? There are so many devices around us that can be considered as computers. Your smartphone, MP3 player, if that still exists, your GPS in your car, your tablet, your smartwatch, all of those are computers. Can you think of the other devices that are computers around you might be using? By the way, things like your smart thermostat, that is computer too. Computers are designed to be able to do any job that their programs tell them to do. So you have to program your computer to do something. You have to set it up to do something. Otherwise, it wouldn't do anything. You have to have the right software in your tablet or your smartphone or your smartwatch for them to be able to achieve their purpose. A program is a set of instructions that our computers follow to perform a single task. For example, Microsoft Word or even PowerPoint that we're using now. Programs are commonly referred to as softwares, but at the end of the day, they're all down to the instruction, to the single instruction in your single program. What softwares have you used till date? Can you name 3? The individual who creates the computer softwares is known as a programmer or software developer. They have a set of skills that help them design, create, test, and implement computer programs. What are some of the fields in which computer programs are used? Can you name 2? Here's a concept for you. Now, the physical devices that a computer is made of are known as hardware. There's different types of the hardware in your computer. You've got input, output, and processing. The programs that run on the computer are referred to as software. So the hardware are the physical devices, and a computer is a system of devices that work together. Here's some examples. We've got input and output peripherals. You've got processing, and you've got your displays. Here's some input devices, and here's your processing. And you'd need storage. We'll cover this in the next slides. The CPU is your central processing unit. Basically, it's the brain of your computer. The main memory, secondary storage, input devices, and output devices. These are the names of the main component your computer consists of. Your CPU is the part that runs the programs, often referred to as a processor. There is so many different types of different processors now today. If we refer that Intel, you can recognize i5 and i7 maybe are the latest Intel creation in this field. Without a CPU, your computer cannot run any software. Doesn't matter what type of software, it wouldn't be able to run it. Running or executing a program is the term used when computer performs tasks that the program tells them to do. So executing. Here is a fun fact. The world's first programmable computer was built in 1945. It was designed to calculate artillery ballistic tables for the US Army. The CPU was 8 feet tall, 100 feet long, and weighed 30 tons. Here's a picture here. Can you imagine that? And then microprocessor came along. Transistors were invented. So CPUs became much smaller, more powerful, and a bit expensive, you can imagine. The second main part in your CPU, apart from your processor, is your main memory. It's basically considered the computer's work area because computers can store programs and results into the memory. Commonly known as random access memory. Random access, the name gives it out. The type of accessing the data is random or direct. You can access any part of the data at any time. Hence, data is quickly accessed, while the RAM, or the random access memory, is volatile. If you turn off your computer, your data is gone. Read-only memory is the main type of memory in your computer. It's non-volatile, so it does not lose the data when you turn it off. That's why it's typically used to store operating systems, or basically system softwares. You've got secondary storage devices as well. Devices that you can store data that is not necessarily to be system softwares. This type of memory can hold data for a longer period of time. The programs and important data are stored in secondary storages normally. Disk drives is a common type of secondary storage. Data is stored magnetically into the drive. It has a lot of mechanical parts. Most computers have an internal disk drive. Some have external disk drives as well. They are used to create backup copies normally. Solid-state drives are the newer type of the secondary or the internal hard drives of computers. They are becoming increasingly popular because there is no moving parts. Hence, they are fasting in fetching the data. It doesn't contain a disk. Instead, it stores the data in solid-state memory. Operates faster, and it's not prone to damage as the previous traditional one. USB drives are small devices that you plug into your computer to use. Optical devices, CD and DVD. These are the other types of the secondary memory. Cloud storage. These days, cloud storage is something that I think everyone now is using. 10 years ago, it was something that we've just been hearing about, and not everyone have access to it. Cloud storage is basically when you use the cloud to store your data. Basically, you're actually using a server, a computer, a supercomputer somewhere over the internet or via your company's private network. The best thing about this type of storage, you don't have to have a physical device with you to access the data. You can access it from any computer. You don't have to be on your own computer. You can access it from any smart device you have. You can also use the data to back up important data that are stored in your computer disk. Now, the second type of the hardware attached to your computer is the input devices. It's any data, basically, that computer collects from people and from other devices is called input. The input devices are the devices used to collect this input data. Common input devices are typically keyboards, mouse, touch screens, scanners, microphones, and digital cameras. Well, can you think of any other input devices? Think of 3. Output devices. It's the other type of peripherals, basically, in your computer. Any data that computer produces or any results that your computer calculates for people or for other devices is called output. The hardware components are the actual hardware that formats and presents the output data. Well, common output devices, monitors and printers. Speakers are output devices as well. Can you think of any other output devices? Again, think of another 3. Now, software. Here is the soul of your computer. It's everything a computer does to control by software. 2 categories of software we have. We have system softwares and we have application software. Your system software is a piece of program that controls and manages the basic operations of your computer, referred to as system software. Your operating system is a system software, utility programs, software development tools. Now, your operating system controls the internal operations of your computer hardware and manages all the devices connected to the computer. Operating systems can be things like Windows or Mac operating system, OS operating systems for smart devices, or Android for your Android device. Utility programs, they perform a specialized task that enhance your computer operation. Software development tools, the programs that are used basically to create, modify, and test softwares. Visual Studio, for instance, is a software development tool. Application softwares basically is the programs that people normally spend time using and running on their computer. Word processing, spreadsheets, databases, presentations, PowerPoint, YouTube, internet browsers. Can you think of any other application software that you normally use? Name 3. Here is another concept. All data that is stored in the computer is converted to a sequence of zeros and ones. This is the language that computer understands. So all the information you can see and read in characters in your computer, in reality, down there in your memory, and the processor of your computer is dealing with it, or the only 2 values can see and process is 0 and 1, the binary. And that's why computers are known as binary devices as well. Computer memory is divided into tiny storage locations known as bytes. 1 byte represents one number. Okay. A byte is divided into 8 smaller storage locations known as a bit, binary digit. A bit are a tiny electrical component that can hold either positive or negative charge. Positive charge that represents 1, or in this dialog here, we look at it as on. Negative charge represents as off, or 0. So this is 1 and this is 0. So how do you store numbers in your computer? The positive charge, or the on positive, is represented by 1, as said, and the negative is represented by 0. The correspondence to the binary numbering system, where all numeric values are written as a sequence of zeros and ones. A single number is represented, or each digit is represented in binary, is represented by 8 values. And these 8 values are a byte. So each digit is represented by a byte. Okay, so if we wanted to represent the number 0 in the binary system, we can have 8 zeros. 1. If we wanted to represent 1, then we're going to have, if we wanted to represent 2, then so this is 2, and this is 1, and this is 0, and so on and so forth. Here's an example. Now, if we wanted to determine the value of on, off, off, on, off, on, or 1, 0, 0, 1, 1, 1, 0, 1, every single digit of these will have a weight in decimal. The first digit will have the weight of 1, the second bit will have 2, third 4, fourth 8, fifth 16, 32, 64, 128 positive values. So what you do is basically you have the corresponding decimal values and you add the on bits only, because the 0 bits are nothing, or 0, they're turned off. You only add the bits that are turned on. And this sequence here represents the number 157. How computers store data. Very important to understand this. The largest value that can be stored in a byte with 8 bits is 255. And that's when you have all your bits turned on. 2 bytes are used, but we do normally have larger numbers than 255. Our data is big data. So what we do, we have 2 bytes together like this. And that then will represent another number to increase the 255 to 65535 or 65,535. And that's basically what this figure represent. 2 bytes all turned on. Now, how do you store characters? Characters are stored in computer's memory as binary numbers as well. Everything in the memory down there is binary. So what we use some encoding systems. One of the most typical and famous and mostly used systems, coding schemes, is the ASCII scheme. Basically, the ASCII scheme turns or represents characters with numbers. And then when we have numbers, it's going to be easy to convert those to 8-byte binary systems. So if you look at this, this is going to be 1, and this is going to be 64. So 1 add 64 is 65. In ASCII, that represents the letter A. The ASCII is set of 128 numeric codes that represents all the letters. But still, ASCII is limited, so we have different types of coding schemes. Unicode, for instance, is an extensive encoding scheme. It's compatible with ASCII, represents characters from many languages in the world, because the 128 can represent most of the English language characters. But other languages have different characters that does not exist in the English language. So ASCII is limited. This is why.